Hello, hello. I was signaled it's time to start another session. The session is titled Go Java Developer. But if you're expecting any obscene scenes during this talk, I'd like to disappoint you right now. And yes, I was asked in the speakers room and whatnot, look, dude, this is Java conference, right? And normally you talk about Java, and today, out of the sudden, you're talking about Go. I mean, how come, right? So, fun fact, I don't work for Oracle or any other JDK vendor for that matter. I'm not a Java champion, so I can speak about any language I please, right? Surprise, surprise. So today it's going to be Go, right? Yes, who am I? My first name is Piotr, my second name is Przybyl. Apparently in Poland, Y or Y stands also as a vowel. This is my Twitter or Telegram handle. This is my Mastodon handle. If you'd like to follow me, I don't know, for Java insights, I don't know, any IT comments or basically pool life advices, that's also doable, right? I entitle myself a software gardener. If you don't know who software gardener is, I really recommend you read this book called Pragmatic Programmer. And I earn for my bread working as a solution engineer for this company called Atomic Jar, right? We are like a startup, test containers, around test containers and stuff. And I also blog every now and then at my personal page called softwaregarden.dev, right? Yeah, so this is me. Usually, for years, since I graduated, or even before that, I was working with Java or JVM languages most of the time, right? So Java was always like somewhere behind me, even when I went on holiday to Spain. The question is, who are you? Who's a Java developer? Nice. Who's doing any other JDK language, like Kotlin, Scala, Clojure? Okay. Do we have any front-end people? Okay, do we have any .NET people? Still a few, yes, hello. Who prefers voting with left hand? And who's after right hand? Okay, we got it. Okay, we know who's who. All right, let the audience be aware, right? So it's like, unfortunately, we live in interesting times, right? I don't have to remind you, don't trust talking heads, even on internet or something, verify on your own, because it's a human thing to make mistakes. I can also make mistakes, right, like everybody else. And surprise, surprise, this talk is not a crash course of Go. So if you are sent here by your boss, because, look, you're a Java developer, right, but we might have a side gig for you because of Go or Kubernetes or something, and maybe you go to that talk of this Polish guy with a funny name, right, and he'll teach you Go in no time. This is not it. This is just a talk, right? The Go course for Java developers is something different. This talk is about what a Java developer has learned or found intriguing in Go, annoying in Go, and can share with you, and what I think now, but my thoughts can change in the future, right? They're subject to change, my opinions. And I can also make some mistakes in Go, of course. And this comes also because I don't like these talks when people or speakers talk about themselves, right? They should be talking about the thing. But I guess this talk is also explained by how did I get to that point, right? So I'm not quite a Java developer, only Java thing, right? So I started my programming journey working in structured programming in C++. I also was earning for living using PHP 3 because tuition wasn't enough at university time, right? And I also enjoyed writing programs with pure C on System 5, like Solaris, Unix, and so on. So I'm used to no having exceptions, for example, or not having objects. And I also did some stuff with Scala and also other languages, right? And this is the story of my life, recently, okay? A year and a half, so to say. So it happened to me that Atomic Jar happened, right? And the founders asked me, hey, would you like to work with us? And I said, yeah, sure, why not? And then, of course, one of the founders, so test containers Java, one of the more known Java libraries. One of the founders is Java champion, so for sure I will join them and I will learn Java, right? Oh my gosh, they use Go too, right? Because in certain aspects, Go might be better than Java, actually. Surprise, surprise. But yeah, it looks like C-ish. There's ifs. There are some for loops. So how hard can it be, right? I've done like maybe C-derived languages share in a time, right? But wrong. It actually can be hard because of this mindset I had before. So this talk, like the audience for this talk is me 2 years ago. If I were able to time travel without causing any time paradoxes, right, and meet myself and give myself maybe a slap or two, like to avoid a few life mistakes and so on, but also like to tell me something about Go, right? To like be more open-minded or something. This is what I would do, right? Watch this recording from like 2 years in the future. So in case you are in the same position, this is a talk for you, right? So things Go shares with Java. They work. Boy, they do magnificent job. They're really awesome languages. They have C-based keywords. They are like in this static typing world, right? They have type inference. They compiled languages, right? So they're not interpreted. They have garbage collection. They provide you with memory safety, unless you don't do like crazy stuff causing memory leaks, right? And they both have interfaces, and they pass arguments by value, right? There are also things that are totally different in Go from your Java perspective, or our Java perspective, shall I say. There is no virtual machine, right? So it's not a managed language in that sense. There are structures, there are no objects. There is no inheritance as we know it from Java. Dependency management is different. It's part of the language definition. There is this go.mode file where you put your dependencies, minimum Go version, and so on. So you don't have like pom.xml or build Gradle or whatever. There are pointers with all the benefits, right? You know it. Concurrency model is different, or used to be different, or it's like Java is catching up. So in this regard, I would say there are no exceptions. Interfaces work in a different way, and generics are kind of a new thing. They appeared just 2 major releases ago in 1.18. I'm not going to be covering generics, and they also like work in a different way. To a certain degree. And this talk is going to be divided into a series of pro tips. So I'm going to give you like pro tips, like key takeaways I hope you'll get from this session. So the first pro tip is when searching for Go, you might search for Golang actually. I mean, this is a joke that doesn't stop giving, that a search engine company created a language and they named it Go, right? It's very fortunate they didn't name it really. That's why when you're looking for like have a question or like you're looking for a forum or Stack Overflow or something, you might be actually wanting to search for Golang in your search engine, right? This is how it works. All right. Another pro tip. And this applies in general to learning, like when we learn as human beings, right? So, I mean, it's different when you teach a child like a foreign language, and it's different when you teach an adult, right? So, as adults, grown-ups, we already have like some patterns in our brains, paths and whatnot developed, and we like to learn by just sort of applying diff to what we know, right? Or trying to express what we try to learn or memorize using the things we already know, right? And this might be not the best strategy when it comes to learning Go from Java perspective. I would really suggest you just unlearn Java or try to forget you know Java, you speak Java, right? Okay, like the concept of variable or loop or conditional or function, yeah, we're okay with this, but that's pretty much it. Everything else, forget it before learning Go. And make yourself empty, make your mind empty and eager to learn Go. Another pro tip, Go playground for the win. You don't have to install Go on your machine. You don't have to, like the compiler and stuff, you don't have to even like go for IDE or something. You may just go and open this thing. Sorry, it's called, Go Playground. You go here. It's, as you can see, it's go.dev/play. You can type your program, right? And then you can click run. And it will run, or if it's not going to run, the thing is going to tell you why it's not running. Of course, there's some limitations. You'll not be able to like pass your local file. Should you like learn this thing or not? But this is like the fiddle thing, right? For Go. And nice thing about it, if you're about to ask, for example, a question at Stack Overflow, or ask a mentor, or share with your colleagues or whatnot, you can click this share button. It will generate a link, like this link, right? And then you can just share with them, and they can point you like what's happening or not. So this Go Playground, if you're just like really into like Go 101, it's a nice place to start, I would say. It's very easy, basically, to begin with. Okay, another pro tip, native executable. So in Java, we have jars, right? In past, or it's still reality for some of us, we have these vars or ERs, or maybe there were also like some other crazy kinds of archives. In Go, we have native executables. So in Windows, that would be this .exe file. And this is what you deliver, right? There is no concept of class path as such. It gets a little bit trickier. I mean, this is the thing that Go doesn't use, but in case you're using a library, and this library is supposed to integrate itself with the like operating system, and then of course it has to have like symbols and do the native calls, and then you need to have that library, right? And then things become like sort of this DLL or .so thingy. But if you have like a single simple process, it's not needed. So how do you do this? Let's try to do. See, I'm in this project, and then and I have this go file. Never enough Go, and then I can just basically go build. See, poor name choices, right? And what it did, it created for me this executable called go, right? And then I can call it go. Let me try to make it a little bit bigger, maybe here. Yes, and then I call it, and this is it, right? This is how you create an executable using go build command, and then it's then you ship it or install it to, I don't know, your Kubernetes clouds, or run it like people's computers, whatever. Okay, and this in a way resembles Growl. So if you have like encountered Growl, played with Growl, you know that like this concept of creating like a native thing that's running out there, right? In this code for this machine. So here I created like a native executable for Linux, right? AMD 64. We could also do so-called cross build in Go. So I could also build for Windows or Mac on my machine, provided again that there is no this DLL hell. Right, so general stuff from like standard library would work. Okay, another pro tip, type inference is very common in Go. Who's using var in Java? Like VAR. Okay, not that many football fans, okay. Like I would say like 40% of the people. So in Go, it's, I would say, the default mindset, unless there are reasons not to do this. And it works like this. Maybe I should try it with code. I mean, slides can take everything, but yeah, in code we trust, right? So you don't see this very often in Go. So there is like var indication that there's going to be variable. We name it, right? So like random number 1 in Go is really after short names, really. And then we can say it's integer. But as you can see, even my IDE says it's kind of like redundant, right? Not needed, over verbose. So this is more frequent. You can just say var rn2, and then because this thing returns you an integer, this becomes an integer, right? Because we declare and define the variable in the single statement. And this thing is even more frequent, or I would say the default, right? So we can, this is not Pascal, right? This is how we say it's going to be a new variable and infer its type. Let's try to see if this thing works. If it runs, yes, it does, right? So as you can see, we got 8 and 15 and 15. How lucky. Yeah, so this is it, right? So type inference is like I would say the default thing, unless you can't initialize it and you just want it to be like have a default value, then you have to go and specify like with default value, it will infer the type from the default value like this, right? This is really rare animal to see, I would say. Okay. Another pro tip. Functions in Go can return multiple values. And this is one of the cornerstones of Go, I would say. And then when you call a function and it returns any number of values, all the values have to be consumed or ignored. You can't just have sort of like return value to be dangling or not used or something like basically, I don't know, unused. And like, to a certain degree, we can understand it as having, for example, this favor tuples in Java or records, right? So then in a way, you can return many things from a single function. And I'm not talking about like returning an array or returning like a collection or something, just more of the thing, like kind of like native. Here it is, another example, sorry, here. Right, so we have a function, and this is how you do stuff in Go. So it's func for function. Apparently, it can be just fun. Maybe it's not supposed to be fun. I don't know. Then func, and this is the name. Here can come the list of parameters, right? And then you describe what you're going to return, right? And in this case, we're going to return 2 strings. So first name and last name. By the way, this is a terrible idea to do in production code. Don't do this. I mean. Okay, and then we return that this is like John and Doe, and we call this thing, and yes, so we welcome John Doe, and then let's say we are not interested in his last name, right? So let's just go and say underscore, and then I can remove this thing here, right? Because I can't just say ln, because then it doesn't compile, because it says this variable is not used, right? So I have to consciously ignore it, like this, okay? And you can see I can return like whatever I please. I didn't test it to the limits. Usually I would say returning that many things would be not so wise. Maybe you'd like to introduce a structure or something, but it's like technically it's doable. All right. Okay, another pro tip. Yeah, so that was it. Go is very idiomatic. So when I was learning English as a teenager already, because when I was in elementary school, Russian was the thing. There were 2 most difficult things to learn in English. I mean, having this, paths in my brain developed already. First, it was answering this American question, how are you? Because we always wanted to give the long and sincere answer because they cared to ask, right? So it's a different story. And then there are these idioms, right? Like close to phrasal verbs. To give you an example, maybe not very fortunate, but it tells the story. I don't know if there is anything relatable in Swedish. You'll tell me. So, in English, you kick the bucket, and let's say you're just learning English or you speak universal language, and when you see a bucket and you kick it, it's like, okay, what's the big deal, right? Whereas when you speak English, it's very unfortunate, and I don't wish any of you to kick the bucket anytime soon, right? Because you'll be dead. And in Polish, we don't kick buckets in that sense. We kick the calendar. I guess it has to hang like pretty low, right? Because when you're sick, you're not able to kick it that high unless you're Chuck Norris. And again, nevertheless. So you kick 2 different things, right? To achieve sort of the same outcome. And this is it. When you kick the bucket in Java, maybe you want to kick the calendar in Go, or vice versa, or something like this. So be careful what you're asking for, right? For example, at Stack Overflow or like experienced developers or something, because things in this sense work different. I'll give you an example. Maybe I should actually start this talk with this, but we've been here with this go. So uppercase M is for months or minutes. Exactly, when we format date, and that's in many C-derived languages. We keep asking ourselves, and there is like a lowercase h, and then uppercase m, or vice versa, or like when you have to format the date like this. And in Go, they've taken another approach. They don't put like 4 y's here, or 2 m's, or 2 dd, or whatever. There is a magic date selected in Go, right? And by just expressing this very magic, I don't know why it was selected like this thing. It's like the epoch for Go or something. I don't know. Maybe someone like came early from like a winter holiday. Anyway, this is it. This is the January 2nd of 2006. This is the precise date, and this is how you manipulate or express how you want the date to be presented or printed, right? See, so there is like a different way. You kick the different thing to get what we do in like JavaScript or Java or whatnot, right? So normally we would do like something like this, right? But we don't do that in Go. And there are many idioms like this, and I would guess it's very advisable to learn these idioms or just familiarize these idioms. So, for example, you ask something like a question, and someone would tell you, just go for the done idiom, right? For example, and you need to know what it means. It's like kind of like a design pattern or something, right? And there's, for example, okay idiom, done idiom, and there are like many more idioms like this in Go. And here I'm gonna present you the okay idiom. And this is the 6, right? Okay, so there are no objects, and there is no null as such in Go. There is a nil, sort of, but it's like it's not necessarily null. And then, like, you're looking for a user with this UID, and you need to know if this user has been found or not. So then, again, we return first name, last name, and the OK if the user has been found or not in our repository, database, whatever, right? And this is just, just for demo purposes. And in case we, like, so example, if it's true, we found our user, right? And this is by definition, or like by how would you call it? I forgot, sorry. If this is true, this has a true meaning. And if this is false, this is rubbish. Usually the default values, right? Like the empty ones. And then we go for an integer and we just see what it is. And here it is, like we get these multi-values, right? And we check the last one, the OK. If it was OK, then it means we can use this thing and that thing. If it wasn't OK, we can't use these things because they mean just nothing, right? They're just rubbish. Yeah, so we welcome Susan Doe. Let's try to rerun. John Doe, Susan, out of luck. Okay, it's still gonna be okay. Okay, never mind, right? But you get the drill. If it wasn't okay, we would know, right? But this is just like an on and off Boolean thingy, right? And this is called OK idiom. Another pro tip, there are no exceptions in Go. And some people say that Go can be summarized in 3 words, if, er, nil. This is like the common pattern. You just see if, er, nil, it means it's Golang for sure. And that's why many people hate Golang passionately. And there is a reason they do, I guess. They do that, I guess. And one of the, like, maybe the way I understand the creators of Golang is that they wanted to make the language to be simple for humans and efficient for machines, right? So, throwing exceptions, unwinding stacks, catching it, and so on, it's not a cheap operation in terms of performance. That's why they went for like no exceptions, right? And to make it easy and understandable also for people, so there are no like jumps or something, and you have to explicitly check the value of the error and everything. So this is it, like easy for humans, fast for machines, right? The core principles of Go. So errors, again, are returned as the last value, and it's opposite than the either, left, and right? In either, if you use Vavor or Scala, right, the right thing is the right thing, and error is the left thing, because it's the only thing that's left. Sorry for my dad joke. Right, yeah, but that's how it works, right? So how it works with errors. Yes, you see the similar thing, and now let's say it's not only enough if we know if this user has been found or not. in OK is just not enough, and we return an error, right? And then we specify its incorrect UID if it's less than 0, or like less than 1, sorry. And then if it's something else, we just say there is no such user, right? And then we return an error. And here we check it. If error is nil, it means these values make sense. If error is not nil, means these are rubbish, right? So, and then we don't care about them. Okay, let's go. Susan Doe, right? We got Susan, and yes, see, incorrect UID, right? So we went not in this branch, but in this branch, yeah, this was the error that got printed, right? And if maybe we can go for 30, and chances are we'll hit like no such user. No, still Susan. Yes, no such user. You see, so there can be different kinds of errors, and we can, because of that, figure out what was actually the reason for not being successful in this branch, right? Yeah, I have shown you the code. Another pro tip: there are no objects, and there is no inheritance in Go. And then there is this mandatory disclaimer about inheritance, right? Some people hate inheritance with passion, and I really don't understand why. It's like inheritance is a very nice tool, and can be used very nicely when you're building your type hierarchy and whatnot, because one thing is another thing. It's pretty valid, you know, for object-oriented programming, you need inheritance and composition, right? So car is a vehicle that has 4 wheels. It's just inheritance seems to be oversimplified or oversimplifying things. That's why it was overused, and hence it was causing so many problems, right? And that's why we coined this mantra. So go for composition, not for inheritance. I'm sorry, like I think it's a BS, right? Go for inheritance when it makes sense. Sometimes it doesn't. And again, the mantras of Go, inheritance might be too difficult for some human beings maybe to comprehend. That's why no inheritance in Go. But we can achieve similar effect by composition, and there is no implements keyword, but we can also implement interfaces implicitly. And I'm going to show you how does it work. That was 8, I guess. Okay, so error interface. Again, the signature of this function didn't change. As you can see, we still return string error. It's just now we return incorrect UID, right? So it's our own error. How does it happen that this thing is an error and this whole function compiles, right? Let's see if I can run this thing. No breakpoints. Yes, see, it compiles and it even runs, right? It's this. We create a structure which is incorrect UID, and this can be the closest thing we get to exception in Golang, right? Because let's say I want to know what that incorrect UID was. I just don't want to know that it was incorrect UID of any sort. Just give me the number that was incorrect, for example. Yes, and then I have to create, like, to function definition, I add this thing. So before the name, I add like the receiver, and this makes it a method on this structure. Okay, so this in a way is this. Think of it this way. Like it's a method that can be called on this incorrect UID. And because this incorrect UID structure now has a method that's called error and takes nothing and returns string, it means it implements the error interface. This thing, when we go here, you see error is an interface, and it means that everything that has this error message, method with taking nothing and returning string is an error. It can have any other methods, no problem, right? But has to have this one. And if this contract is not satisfied, let me, for example, let me rename it to error 2. Suddenly the thing doesn't compile, because now this structure is not an error, right? It doesn't implement errors interface. So this is how we do this, right? And then we can return this error, and basically the thing works as it used to work. And if there's no error, yeah, you return, or we return a nil. And everything else is pretty much the same. Oh, except this thing. This is like something similar to instance of, or these multiple catch clauses in Java, right? So we can check if this error, like try to match this error to be this incorrect UID. If we are successful, it means we're dealing with incorrect UID, else we might be dealing with another kind of error. And if you're using this mechanism for anything else than error in Go, I would say it's a code smell, but it's kind of like, again, an idiom sometimes for handling errors in Go. Yes, so we've covered two things, errors and returning or implementing interfaces. Another pro tip, sometimes we can inherit via composition. Not sometimes, like we can always do that in Go. So we sort of like inherit behavior by composing or putting stuff together inside. I'll show you how it works. Here we go. Those bad jokes, sorry. Yes, so interfaces in Java are usually able, closable, comparable, runnable, and stuff like this, right? In Go, they are there's a swimmer interface or like structure. There's a like runner, and this is how you name stuff. And we have swimmer, and the swimmer can swim in a certain style, as you can see. So then we can go, and as I told you, or as I promised you, this is kind of like a this alias. We can say that the swimmer is swimming in this style, right? So there's a swim method on swimmer. And then there is a runner, and runner again can run in a certain style, and we can check how it run, and then we have a hippo. And we can create a hippo, right? And we can say that hippo inside has swimmer and runner. And in Java, what we would do, it would say something like this. It has a field S of type swimmer and field R of type runner. And this is also like valid Go code. It's just when you don't alias these things, it sort of means that the hippo becomes runner and swimmer as well. Okay? And then, I mean, we can create a hippo. So this is how we create a hippo. So hippo consists of like swimmer, swimming slow, and runner running fast. Some people say that actually more people die in Africa thanks to hippos than to lions, because hippo doesn't look so dangerous, right? And then this is like what you would expect. So inside hippo, there's a swimmer, and you can call swim on this swimmer, and similar for runner, right? And I guess this code should run. Let's see if it runs. Very nice. It's just, you can also do it like this thing. And you can see it was swimming and running twice, right? So for these things together. If you go for this composing without aliasing, it means the hippo becomes swimmer and runner. And therefore, hippo can swim and run without, breaking this law of Demeter, like playing with the things that are inside. So as you can see, this is in a way how you can inherit behavior in Go, right? So despite not having inheritance and not being OOP language, right, you can still create or compose structures and inherit the behavior that is assigned to the structures composed inside. I told you, unlearn Java, right? Another pro tip. Methods and functions can't be overloaded. Again, simple for humans, fast for machines, right? This is how it works in Go. And still, again, I myself test stuff in IDE. I mean, who would read documentation, right? Come on. Yeah, so I have this, again, structure called something, and I'm creating two methods, do and do a thing. And in Java, normally, we could overload this name, right? And we could basically do, again, because this doesn't have parameters, this has just one parameter, so we know which one should be called, right? And in Go, it said it's too confusing. No. This name is already used, and it's not because they have do while, right? Whenever you do something, it has to be a totally different name, like one that's not used, right? Even if we could tell by different set of, or sorry, I should say like a list of parameters, that it should be a different thing. Apparently, this is how it works, right? So easy for humans to learn. Although a bit annoying, for example, for Java or C# developers, right? Used to overloading. Another pro tip, access modifiers Haben wir jemand aus Deutschland hier? Sehr gut. So, access in Go works like nouns in German. I'll show you in a moment, right? So there are no access modifiers, but we can block access. And how does it work? We have this utils package. I mean, we shouldn't have the utils package, right? But there's always this string utils, and we have to put it somewhere, right? So sooner or later in any, I mean, the project is not legacy if it doesn't have the utils package, let's be honest, okay? So I made it like a more like real life for you. And as you can see, I have this thing which is accessible and this is inaccessible. And it's not because Go's compiler is smart or has like ChatGPT or whatever inside. It's because this looks like a German noun and this doesn't, right? Uppercase means it's accessible. And lowercase means it's inaccessible outside the package, right? And this also, it's only this thing, right? So inside, when I call this say hi function, inside this package, right, could be another file, I can access both. But when I go to another package, right, the main package, then the inaccessible is, well, oopsies. It's inaccessible, and it's because of this lowercase I, right? And that's it. There's no more access. It's not even like remotely close to Scala, which went opposite way, where you can have like private this or whatever. This is it, simple, as German. It just follows simple rules. Sehr gut. Go arrays aren't like Java arrays. You see the square brackets, you see 42 inside, and you say, yay, arrays, I know how they work. Good luck with this mindset. They don't. Arrays in Go are values. They're values in a sense just like primitive types in Java, like integer or long, I mean the lowercase ones, right? I mean, that's not exactly true, but it's like getting us into the direction of Valhalla project, where Valhalla is about, like if you, for example, have a million objects of exactly the same type, there is no need to keep a header of every object, right? So let's just keep one common header for like the whole array, and that's it. So make this thing more like look and appear and work like primitive type. And so are arrays, I mean, in more or less in the same fashion in Golang. Okay. Code usually is better than just slides. I mean, I could put anything. I'm not an architect, right? So, you know, architects, they put their fancy boxes, arrow here, arrow there, like implement, right? And then you end up with, you know, okay. Yes. So this is it. Let's see first if this thing works. I should have proper tests, but this is like a very introduction thing, so tests are skipped. And it seems to be working. Very nice. Let me just try to make this a little bit bigger. Come on, scroll. Very nice. Okay. And I am creating an array of 3 strings. And because of this, I named it A3. It's not like the size of the sheet of the paper. It's just A3. Stupid name, but works, right? A, B, C. 3 strings inside this array. And I have a function that just happens to accept an array of 3 strings. And I print first, second, and third element of that array. Easy so far, not surprising, I hope. I can also declare an array this way. I don't know how many elements I'm gonna declare here in this line, so let's say ... I trust you that you can count that many, compiler, right? And it would like count it and put 3 on my behalf. And that's why this print A3 also works. And then I can create another array, and just like, you know, another variable, and by this they will be pointing to the same array, right? And then, perhaps no surprise, when I replace the first element in A3 bis to DD, when I print this thing, it's DD. But why on earth wasn't DD printed here? And this is it, because arrays are values, right? Like integers. If you swap 2 bits in an integer, then it's different integer. And so it is in here, right? Just because it's not like a new reference to the same array. It's a new value. And it has like very positive consequences, for example, because then instead of putting it on heap, we can put it on stack. And when we're done with the method call, we can just unwind the stack, and it's a much faster operation than garbage collection, right? Performance, mind you. And that's why this thing doesn't work. I can't reassign to this variable an array that has 4 elements, because type of this variable clearly says that it's 4 elements. Sorry, 3 elements, not 4, right? So in Java, that would be doable, because a type of an array doesn't contain the size of the array. But in Go, it's different. Okay, so I can create a new array of 4 elements, but then it complains that it's not used. So I try to use it, and surprise, surprise, it doesn't work, because this function expects array of 3 elements, and I'm passing 4 elements. Yeah, I see you smiling. Yeah. Very, 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 very good for, I don't know, like a Friday party? Dear nerds? Okay. Yes, so it can't be that people are not, like in Go, are working always with this, right? Sure, they don't. And there's another concept, it's called slices. And slices are kind of like wrappers around pointers and arrays. The closest thing in Java would be array list, I would say. So we know that inside an array list, there's an array inside, and we put items into this array as long as they fit. When they don't fit, suddenly there's a new array created, it's bigger, then there's whole array copy inside, and so on and so on. And more or less, this is how slices are working in Go, but they can be surprising. So they are size independent, unlike the arrays, and append friendly. But if you don't get pointers, you will get bugs in production. I'll show you more or less how it works. It works like this. Another example with slices. Yes. So as you can see, now we don't have this size, which means it's a slice, not an array, mind you. And this is another another idiom. This is for each loop. I'm ignoring the index. I'm only interested in the actual element that's inside. Let's run this thing. Very nice. I have this slice of 3 elements. I can print it. It's ABC, no surprise. I create another slice and assign it to this variable. Then it's DEF, very nice. And then how would replacing work? When I I create another variable from this slice, and when I replace the first element of this new copy to be DD, then very nice, both are replaced, right? Unlike arrays. But then if I have to here append another element, so to this alias, I'm going to append G, and I print this thing, it prints DDEFG. Okay, so you know what? Putting this DD was a mistake. Let's put back this small lowercase d into our alias, right? And looks how it works. So it worked for the alias, and it didn't work for the original one. So why replacing worked before appending and it didn't work after appending? Because appending detected that the array inside this slice can't fit the appended element, which means that we have to create another array, right? And copy the elements there, so that from there on, they're just pointing to 2 different arrays, right? So you see, just because of append, the results may vary. Please be careful about this. So see, slices seems to be more arrays than arrays from Java point of view, but still they can sort of backfire. Told you, have a different mindset. Okay, another thing, use Go format. And this is what I love about, okay, indentation. 2 spaces, 4 spaces, 8 spaces, 3.5. Exactly, we've all been there, right? We've all been there in the teams fighting about such a rubbish thing. In Go, they have this. They have Go FMT, basically this, boom. And it's difficult to show within IDE because I have my IDE working, but let's say I put spaces here, tab here, 1 space here, and so on. And then I would try to switch to terminal. My IDE already applies what? It applies exactly this, Go FMT. Which means there is one defined format for Go source code, right? And there is no fighting, right? In Shakira's hips and okay, cache. Oh, sorry, too many. Okay, we're running out of time, and I have still 2 pro tips for you. Threads might be too heavy and not flexible sometimes. We've learned that in Java as well. So first there were processes. We found processes too heavy, so we went for threads, and we were happily implementing this thread per request pattern. And then we discovered that threads are not enough again, right? So now we are into, okay, so there was like a reactive word, there were like coroutines in Kotlin, right? We are having now virtual threads from Project Loom. Go did it like from day 0. They have the thing called goroutines. And they are lighter because goroutines, just like virtual threads, are implemented in sort of like continuations and can write any threads from the operating system, right? So we don't have to create like a new or request new threads from operating system. And like I said, this, I mean, the closest thing I could think of from our Java ecosystem is Loom, right? Yes, so how does it work? Goroutines demo. Printing, we're gonna print a string 100 times, and we know like which time is it, right? When we print it. And this is it. So maybe let's try to see if it runs. It should, it runs, very nice. So there was this usage pattern, or maybe, I don't know if it qualifies to be an idiom. Anyway, there's a wait group, and we say we're gonna wait for 2 things, because just like with daemon threads, if you run goroutines and the main thread exits, the whole thing will just exit. That's why we have to ensure that we are not done unless this is done and this is done, and we can say defer inside a function in Go, or like a goroutine, like function, and this means that this would be the finally from sort of like try with resources, right? So when you see defer, it means like everything else like wrapped with this try, and this is like the final thing. Always do this, okay? So then we say that I'm done with this waiting group, and this will be done with this waiting group, right? That's why we have the delta set for 2, and this is an anonymous function, right? And just before any function, you can put go, which means this function, anonymous or like declared, will be run in a Go routine. Easy, right? And we have this first function who says hi, and this other says hello, right? We can test it. You say hi, and you say exactly. And let's say there's 100 people here. Clearly, there's more than 100 here, and like maybe there's 100 here. But yes, exactly. It's just if I ask you to do this concurrently, you see this is how it works. So we said hi 83 times, and then we start saying hellos, right? So as you can see, this thing is running concurrently. So we are not creating new runnables or new threads, not starting them. We just call go and function, and then it's run in its own Go routine, and it's done, at the same time, more or less, right? So there's different concurrency model, and there are no monitors. I mean, I guess there are like libraries with monitors, but like here you use the wait group, or we use the wait group. You can go also for like done channel or like other stuff. The last pro tips, down calls in C are quite simple. So it turns out not only Python can be wrapper around C, and like maybe, or not maybe, we should be able to achieve the same using Project Panama in Java, right? And how does it work? And yeah, okay, so this is it. It shows very nicely because this JavaScript plugin sees this and understands this as a comment. So there is like, this is kind of like ugly. There is a comment, and you just put this comment above this import C, right? And thanks to JetBrains, we can see in inside this comment, we can see code that is C unless we can't and something broke after the upgrade. Yes, it might be the case. Anyway, this is it. So see, here we can call this greeting, and we can check which thread from the operating system that is. So basically, I'm creating this greeting as a C string, and I'm calling this greet function from this C thing here 100 times, right? And I'm gonna do it again, 100 times for hi and 100 times for hello. It's pretty much the same. It's just this time I'm asking C, hey, please tell me which thread is actually being used, right? So see, this was thread this number for hellos, and for highs, it was another number. Yeah, see, these were different numbers, right? So this is how we can make a downcode for C. Upcodes are also possible, but they are somewhat more different, and you might be asking yourself, why so much ceremony? Well, C is a language without garbage collection. You malloc, and then you free, right? Whereas Java, Go, C#, you name it, are languages with garbage collection. And that's why we can't just pass things to C and back again, because garbage collectors might be compacting stuff, kind of like defragmenting our memory, our heap, right? Which is something that is unfamiliar, unheard of in C. That's why we need these bridges and clever memory, access and whatnot. That's the whole thing. All right, if you got hungry, I recommend you reading a book called Learning Go by John Bodnar. Very nice book. There is a Practical Go by Dave Chaney, very well-known person in Go community, like a series of articles, conference talks, and whatnot. There is a Go by example, like a public documentation from Go. There is Just for Funk. It's a bit oldish, but it's still like very decent to learn channel on YouTube when folks explain different things related to Go or Goland. Takeaways for you. Unlearn, learn, test, and grow your brain. Learning languages, playing chess, and also like learning foreign, like different computer programming languages grows your brain. It's very good, right, for you when you get to retired or whatnot. Experiment with Go, have lots of fun, right? Enjoy boring and machine-friendly language, and appreciate both Go and Java and other languages, right? And here comes the thing. At Atomic Jar, we finished our Series A. We raised quite substantial amount of money, and we are about to grow our team. So if you'd like to join us as like a Java developer or Go developer, or we might be even looking for some front-end people, you're also welcome to join us. You can like ask Sydney, or you can approach me, or Oleg will share like or answer your questions should you have any. Always and everyone, please feedback, talks at any conferences or meetup. You're doing it for yourself, not for me, not for organizers, for yourself, because next time you'll be given better talks, basically, right? I will accept feedback in any form, also paper forms. Please rate this talk. This is it, like this anonymous poll. If you'd like to, I don't know, like your name or something, if you'd like to know me, let me know how it was, what should I improve, what was okay, please let me know. Tack så mycket for coming here today and like doing Java conference, right? And if you'd like to follow me for like Java insights, Go things, or pool life advices, this is me on Twitter or Mastodon, and these are the slides and everything for you. Thank you very much for coming. Enjoy the rest of the day.